welcome to lab number 7. Before we get started on that, a few notes as far as lab number 6 and your submittals. It looks like everyone is doing really well on that, turning those in. And I'll go ahead and pretty soon get started grading them. The way I intend to grade them is I'm going to go ahead and just print them out and grade them like I would if you were to hand in a submittal. And then I'm going to try and arrange the pages in a 2x2 grid. So 2 high by 2 wide, so that's 4 pages. Most people, it looks like they are just 4 pages. And take a decent picture of it, and then I'll email that picture back to you, so you'll be able to look over those and get feedback on that. So that's my intentions. That's the way I intend to try and grade the exams and whatnot. So we'll see how that works. A couple things I've noticed on lab number 6 is I graded, since this is your first submittal, I'll put lots of red marks on it, suggestions, things like that, but as long as it's complete, as long as it's got the pieces, I'm not going to take off any points. So that won't be the case going forward though, so you'll want to take into account those marks that I put on that and try and improve your upcoming labs. One thing that I noticed in the lab was that if you're going to make something on engineering paper, that's great. Draw it on engineering paper and scan it in, but it needs to be neat. You need to use straight lines, use a ruler, straight edge. It needs to be high quality, so make sure that you're thinking about that. The other thing is you really took the reference to heart. A lot of people actually drew their own chips and then still gave the lab or me credit for that. So you don't need to do that. It's only if you use something from someone else. So, and I'll make those comments on your labs also as you turn those in. They're due at Thursday at midnight, and then I'll be grading them and getting back to you at the beginning of the next week. Well, let's go ahead and look at laboratory number 7. Again, this is our designer here, and just like last time, this is lab number 6 right here, so we won't pay much attention to that and concentrate just what we have here with our laboratory number 7. So if we look at the handout for laboratory number 7, it says construct a logic diagram, and again, this is going to be pretty small on the screen, but you've got this in hard copy, you can download it. It says construct a logic diagram for a 2-bit BCD to decimal converter, use 2 input NAND gates and NOT gates. So that's actually even on the website. So if you go to the lab tab, the sub-tab for lab, and there's help on lab number 7, and you've got this. So don't just copy this. I mean, make it your own, redraw it, however you're going to do that. But there's the circuit, and there's the logic diagram. You can do 4-bit. It's just longer and more involved, but a 2-bit gets the idea across. So that's that portion of it. I've got the truth table. Then detail the above circuit so that it could be built. Use a 7400. Remember, that's the universal chip, the and the 7404. Actually, we could just build this thing all out of 7400s, but I did it with a 7404. So we've got that right here, and again, just like laboratory number 6, I did not complete this. I started it. I've got my power, I've got my ground, and I've got a couple of the circuits in there. So I didn't want to spoil all the fun for you, but you figured this out on the last lab. Should be pretty straightforward on this lab. Probably truth be known on this lab is actually easier or shorter than the last lab, because I'm just going to demonstrate this 7448, because modeling it is going to be quite a bit different than trying to model this 2-bit. So we'll have you model this 2-bit, I'll demonstrate this 7448, and we'll hopefully call it good at that. Well, let me go ahead and do that, because the step number 4 is to model the thing. So I've built this, I've built both of these. You're going to be modeling this 2-bit. You don't have to model the 7448 and the 7 segment, but I did build it here. So let's see how this works. Again, I've got that over here. I've got my inputs A, B, C, and D, and then I've got my outputs over here for the 2-bit 0, 1, 2, 3, and then of course I can only go through 3 with that, but I can continue to count with this 7 segment. So let's see if we can do that here. We've got, let's see, well, if all the switches are down, I've got 0, and that makes sense. The 0, it's activating on a low, so that's off, so indicating 0. Or if we wanted to cheat down here, we could see that that's a 0. One thing to note too is troubleshooting. You can see there's lots of wires on this thing. Having a good circuit diagram, again this one was not complete, but having a good circuit diagram and crossing these off as you build it is really important. I always tell students there's no troubleshooting like building it right the first time, but sometimes you make a mistake, things aren't right, you have to troubleshoot it. So what I always do is I just grab a wire and hook it into where I've got a spare LED, and first of all test my LED. So if I do that, it's plus 5 volts and it goes on, that's great, and it's ground. This one's kind of nice, it'll even show a ground. So now I know that this is showing me good information, and I could go ahead and probe the circuit and check and see what's high and what's low and things like that. So with this wire, and you can start to then sort that out pretty quickly. So that's a little troubleshooting tip for you. They make logic probes that a little more sophisticated, but you can do your own logic probe with a piece of wire. So I apologize, some of this is probably a little hard to see. I'm filming almost in the dark so that you can see the LEDs and whatnot, so the typed material is probably not at optimum resolution, but again, hopefully we can get this handled. So we've got this showing 0 here and showing 0 over here. I hit 1 and we've got, oops, this switch here on B is a little bit finicky. There we go. We've got 1, so, and 1 there, and then back there's 2. That's working, 2, and finally both of those up should give me 3, and we've got 3 there. Now we've gone past the 2 bits, so this is going to become nonsensical. But if I wanted to continue on, there is 4 and 5 and 6. And then 7, and then 8, and we could even go on further. If you take 8, and we've got 8 and 2, that gives us our 10, and we start to go up through the hex characters with that. So I think that works. You'll notice that I put resistors in here. I didn't have 150 ohm resistors, so I used 100 ohm in a series with a 47 ohm. That was fairly close, and probably, truth be known, I could have got away with just 100 ohm. That would have made this a little brighter, probably a little better for filming. The reason I didn't put just one resistor in, a lot of times people will want to cheat and just put the resistor on the ground side, which would protect it, but you're going to have significant differences in the brightness depending on how many segments you have lit up. So that's why we have a resistor on each of the segments. I didn't give you a pin diagram on the 7448 or the 7-segment common cathode. I don't have that's in an appropriate form to release, so I don't get into copyright problems, but a quick Google search would give you that if you wanted to explore that further. Going back in history here, I've got kind of a fun little circuit that a student built. This was actually his name's on the back of it, and the date, it's 1989. He built this and gave it to me. It's kind of fun. He built the power supply. I turn it over, but I don't want to show its name. On the 1 in a million chance this video goes viral, or I guess 1 in a billion. Sorry for not being realistic there. But he built the power supply, and then he made it so it would cycle through 0, 1, 2, 3. But you could also, if you turn that switch, then you can just put in your own input. There's a 2, there's a 4, and there's a 8, and so forth. So if you've got some extra time, you could do a little mail order some of these pieces, and start to build your own circuit. It's kind of neat. I've kept this, and will continue to keep this. It's kind of a neat deal. Let's see, where are we? As far as the laboratory goes, you're going to go ahead and model that thing, and you don't have to model the 7448 and the 7-segment display. And then just like with laboratory number 6, and most of you have done well with that, you're going to prepare that executive summary, so, and summarize what you did. The one thing that I noticed with your attached pages, it looked like some of you didn't necessarily reference those. Don't just staple those pages on. You want to reference those pages. You want to give the circuit a name, circuit 1 or figure 1 or diagram 1, and reference that by name in your summary. So it doesn't look like they just stapled pages onto the back of that. Well, let me go through my notes here, make sure we've covered stuff. I think we've got Lab 7 pretty well taken care of. Remember, next week we've got our first exam that is over the digital work. And I think I've mentioned in the past, not that the other exams are going to be horrible hard or anything, but I think the digital exam is probably going to be the easiest. So make sure you get the points on that. That's a good time to really get ahead in the class and get some points as you go forward. So I will be emailing that exam to you on or before next Wednesday at midnight, and then you'll have to turn it back into me. You'll just email it your work very much like the way you submit the lab. You just work it out on engineering paper and either take a picture of it or turn it into a PDF and email it back to me by the Thursday at midnight. So that'll be going out next week, and I'll send the exam out with directions on how to submit that back to me. If we look ahead to, you want to start transitioning out of digital and back into the analog world of reading Chapter 14 and Appendix E in Nelson. That'll get you into frequency characteristics and Bode or Bode diagrams. So make sure that you're keeping up with that. That'll get you into the homework where you're starting to, again, just like you did in Engineering 201 and 202, actually work out the homework and keep that in a notebook. And those homework problems, I think there's only about 23 of them. They are deceptively long. I just hit some of the high points in my solutions. There was a lot of scratch paper that I didn't include. So don't think that 23 questions, well, I can work those out in an evening. That's not true. So those are fairly long problems. So you're warned on that. The other thing is laboratory number 2. So in 2 weeks, next week's midterm, week after that, we get into laboratory number 2, which is Ltspice. So I've got 4 circuits that show 4 important things that we've studied: DC, AC, mutual inductance, and 3-phase. And we want to figure out how to model those with Ltspice. So you want to start thinking about downloading Ltspice. I've got the links on the website, so you can download that for free. Some of you have noticed even simulated Lab 6 with Ltspice, so you're getting some practice with that. That's good. But start thinking about that. And again, like I mentioned, probably one of the biggest stumbling blocks for students is sitting down and working those 4 problems by hand. They seem to have forgot a lot in the past, so that's a good thing too. Work those problems out by hand. Figure out what the answer should be before you start seeing if your computer simulation is correct. So those are all things that you can think about going forward. I think that gets me to the end of my notes and my to-do list. I hope your term is going well. I hope this class is going well. I hope your other classes are going well, and you're finding a new norm and how this works out, and you're able to communicate with your supposed lab partners. Hopefully you're talking to your classmates and whatnot. I think that's really important. From what I've seen with laboratory number 6, you're right on target. You're turning in good stuff. You know, some of you I will probably make a lot of red marks on it, but that's okay. That's the learning process. It's still good stuff at this point in time, and we're right where we should be. So take heart, keep up the good work, and I'll be talking with you soon. Take care.